everyone, and welcome to Keystone Shitterings. Today, we're going to be talking about integrating exponential functions. Today's video will be quite short. We're just going to provide a bit of a formula and some examples. This formula is based off the previous and introduction to our integration video. So if you haven't watched that, I would highly recommend watching that before watching this, just to provide more background and understanding. Awesome. So the formula, as we can see here, so from the last video, we said that this is the integral, and that just pretty much means the reverse of differentiation. So what we're integrating here is e to the power of x dx, okay? So let's break this down. E to the power of x is the function we are integrating, so it's an exponential with the power x, which is our parameter of interest. And the dx here indicates that we are integrating with respect to x. Awesome. So let's go on to the right-hand side, the output of this. So as we can see here, we still have e to the power of x, which is the exact same. So in every integration of exponentials, the original exponential function will remain the exact same, but you always multiply that by the derivative of the parameter at the top, all right? So here we have x dash representing the derivative of x, where x could be anything. It could be x squared plus 2. It could be x in itself. In that case, the x dash would be 1, x something. It's a function, and yes, awesome. And then the plus c, if you remember from last video, representing some constant because it is the reverse of differentiation. And remember, I'll just give a quick recap. Let's say f of x is equal to, let's say, 2x plus 3, then f dash of x is equal to 2. But as we said, integration is the reverse of differentiation. So if we wanted to find a function f of x, we would have to integrate f dash of x with respect to d of x, obviously, which is equal to, so f dash of x is just 2, so that'll just be 2 of x. And then, but we wouldn't have any information on that being a plus 3 there. So that's why we just add the plus c in this, only in the case where there's no bounds on the integral. If it was between 2 points, then we do not add the plus c. Awesome, let's go into 2 quick examples. And yeah, so the first example is e to the power of 5d of x. Now I want you to be careful here. What's happening here? So the, you may say e to the power of 5, all right, but there's no x involved here. There's no the parameter we're differentiating by. So this here is just a constant value. So what we can really do is just sort of take this out. We can go e to the power of 5, right? Integral of 1 dx. Just leave the 1 outside because 1 times e to the power of 5 is still e to the power of 5. We can just take that out. And obviously the integral of 1 is just x, because remember we add a power, so it would be go from 0 to 1. So the integral of 1 dx is just x. And therefore we would go on to get e to the power of 5 x, and then as we said before, we have to add that plus c as we are unbounded in this case. Awesome. So let's go into the last example for today. We have e to the power of 3x plus 2 plus 5 d of x. So just for the purpose of this, I just want to, sorry about that. Just for the purpose of this example, I just want to make 3x plus 2 equal to u, just to show you that we have to differentiate the power of the exponential. So u to the 3 of x plus 2, if we're differentiating that with respect to x, that obviously is just 3 because the x drops off and this has none, so it goes to 0. So as we said before, let's go back to the formula. We get the derivative of the power of the exponential times that with the exponential. So we have the 3, which is the derivative of the power of the exponential, and we times that by e to the power of 3x plus 2. And then, as we said, we saw in this example here, That's just like taking the 5 outside and integrating by 1. So we get 5x. And then once again, it's unbounded. So we plus c. Awesome. So that comes to the end of today's video. I hope you have learned something and best of luck with your studies.